Welcome dear students, we are on CEC Gurukul lecture. In the today's lecture we discuss the DC motor, that is the part of the electronic equipments, and we are in the series of the electronic circuit. So this motor is very important in the electronic gadget. So previously we have discussed the AC motor, now we will discuss the DC motor. What is the DC motor? As the name suggests, DC is the direct current. So the DC motor is another main type of electric motor that only runs on direct current or the DC current, and there are no phase in the direct current. That's why DC electric motors only uses two wires to run. So these type of DC motors are the first motors to be invented. First the DC motor was invented, and it is easier to control the speed by only varying the supply voltage. It means we can control the speed of the motor by changing the voltage which we are applying. So and this DC motor are very simple starting, having the very simple stopping, accelerating, reversing mechanism. So this DC motor is easy to use. The installation cost of the DC motor is very cheap, but the maintenance cost increases significantly with the increasing size and power output of the motor. So the basic working principle of DC motor based upon the Fleming's left hand rule. The DC motor works on the Fleming's left hand rule. So a current carrying conductor inside a magnetic field experience is a force of thrust mutually perpendicular to each other. It means this type of the motor working on the Fleming's left hand rule, having the current carrying conductor which experiences the magnetic force, and that force of thrust mutually perpendicular to each other. So DC motors are briefly classified into the following types. The two main important types are the brushed DC motor, or second is the brushless DC motor, and another type is the coreless or ironless DC motor. We will discuss one by one in detail, and we will discuss the types of the brushed motor and brushless DC motor. First we discuss what is the brushed DC motor. As the name suggests, what is the DC motor? That uses the brushes and the commutators. That's why it is called the brushed DC motor. So DC electric motors which uses brushes and commutators are known as the brushed DC motor, and they are used for connecting a stationary circuit with the rotating circuit. Through this brushed motor we can connect both the stationary and the rotating circuit. In such case, the rotor winding of the motor is energized through the conductive brushes. So we need the excitation in this type of DC motor, that is basically the energized. So the motor is energized through the conductive brushes, and these brushes uses in the excitation or energizing the motor. So the disadvantages of the brushes is that it requires a frequent maintenance due to the continuous sliding of the brushes and the spark generated between them. However, they are quite simple in design, but they are expensive. Now you see on the screen that here we are having the brushed motor. You see one side we are having the magnetic field, that is the north and south pole, and that work on the Fleming's left hand rule. Now the carrying conductor is in between the magnetic field, and the DC source is supplied to this brushes and commutator, and the windings you are seeing on both the side, and there is a armature where we are having the binding. So this type of motors are the brushed DC motor, and these brushes will move as a power is supplied, DC power is supplied. So the brushed DC electric motors are further classified into three parts. Number one is the separately excited motor, next is the self-excited DC motor, and third is the permanent magnet DC motor, separately self-excited and permanent magnet DC motor. We will discuss one by one in detail. Now the separately excited DC motor, that type of motor are, as the name suggests, excitation is required. That type of motor has a separate excitation. It means the excitation which refers to the energizes all the field windings, which is known as the stator's winding. Both the winding, that is the field winding, and armature's winding are connected with a separate power supply. That's why it is called a separate excitation DC motor, because both are connected with the separate power supply. You see here on the screen that in such a configuration we have independently strengthened the magnetic field by increasing the DC excitation without changing the armature current. So you see here on the left hand side armature there is a supply, and right hand side we are having the field supply, and that is a field we are having here. Positive and negative terminals are attached. So these both are attached with the separate excitation devices. That's why it is a separate excitation DC motor. Now you see, this is the main distinction between the armature current does not flow through the field winding. Now next type of motor is self-excited. As the name suggests, it automatically excited, means started. Such type of the brushed DC motors has a self-exciting field winding, and this type of field winding is electrically connected with the armature winding. So a single power source energizes both the windings. Winding uses a single power, therefore it does not require the separate excitation source. The field winding can be connected in series, can be connected in parallel, or the partially connected series as well as in the parallel, and the partially series configuration with the armature winding. So this type of self-excited DC motors are further classified into the following types. One is the series wound, second is the shunt wound, and third is the compound wound. On the basis of the wounding, we classified this self-excited DC motor, where we required only the single source for energizing the both the armature and the field, magnetic field. So this type of the self-excited DC motors classified on the basis of its arrangement in the series, shunt, and the compound wound. Now in the series wound DC motor, we know that this field winding is connected in the series with the armature winding. Now you see on the screen here, this is the winding. Here you see the supply, DC supply is here we are using, field winding is there, and armature, and here we see the field winding is connected in a series. So series wound DC motor, the field winding is connected in the series with the armature winding. Therefore the current flowing through the field winding is same as the current flowing through the armature windings. Now you see here that the speed of the such electric motors varies with the varying of the load connecting to the motor. So output, it depends upon the supply we are giving to the motor. So the speed will also depend upon the magnetic field which we are applying. So the shunt, next type of is a shunt wound DC motor. This type of motor also called the shunt field winding, and the DC motor have the field winding that is called the shunt field winding, which is connected in the parallel with the armature windings. So it allows a full terminal terminal voltage across the field winding, while both the winding have the same amount of the voltage across it. Means we are applying the same voltage, but it is in the parallel. While the supplying current is divided into the field current and the armature current. Such type of electric motors are used for its constant speed applications, since it maintains speeds over a range of the loads connected with it. So you see here the field winding is in connection with the parallel. So shunt winding refers to the winding connected in the parallel, shunt wound DC motor in the right hand side, you see. Now next type of DC motor is the compound wound DC motor. This compound wound DC motor utilizes the feature of both the series wound and the shunt wound DC motor. Both we will use series as well as the shunt, means series and the parallel we will take in the combination of the compound wound. It combines both the parallel combination as well as the series combination of the field and armature windings. So due to the combination of the series and the parallel windings, the compound wound motors can be classified further into the following types on the nature of the winding. Number 1 is the cumulative compound and second is the differentially compound. Both will discuss. In the cumulative compound, when the shunt field and the series field winding generates flux in the same direction, then the shunt field flux helps to increase and maintain the series field flux. So the motor is said to be commutative compound wound motor when the shunt and the series field winding generate flux in the same direction. The total flux generated in such a case is always greater than that of the original flux. That's why it is a cumulative compound. And what about the differential compound? When the shunt field and the series field winding generate flux in the opposite direction, so the flux reduces. In the previous case the flux increases, but here in the differential compound the flux reduces, the effect of each other. So it is said to be the differential compound DC motor. The total flux generated is always less than that of the original flux, and they do not find any practical application in the industries. Now both the compound motors can be the short shunt and a long shunt depending on the arrangement of the windings. Short shunt and the long shunt DC motors are explained as. Now what is a short shunt DC motor? This type of motor, short shunt DC motor, if the shunt field winding is only parallel to the armature winding, then it is in the series with the field windings as shown in figure below. You see, it is also known as the compound wound motors. That is the short shunt DC motor. You see here, the shunt field winding is only parallel to the armature winding. You see here, and it is in series with the field winding. From the DC it is connected in the field, but here with the armature it is connected with the parallel. Now the long shunt DC motor, apart from this, you see the DC motor in the long shunt motor, if the said shunt field winding is in the parallel to the both the armature winding as well as the field winding. Now next is the permanent magnet DC motor. Permanent DC motor, or it is also known as the PMDC motor, permanent magnet DC motor. So the motor, which is another type of the brushed DC motor, and it has a usually armature like the rest of the brushed DC electric motor explained below. Here you see that here this is the very simple form of the permanent magnet. You see on the both side we are having a south and north pole magnet, and in between that it is connected through the DC power supply. However, there is no stator or the field winding. The magnetic field is generated using a permanent magnet placed in the stator. So we use the permanent magnet in this. When the armature winding carrying the input current is placed inside the north and south pole of the magnet, the magnetic field interact with it, and the armature experience rotational field. So because of this it will rotate. The permanent magnet generates a fixed magnetic field which is designed at the time of the construction, and it can't be changed after that. The permanent magnet we are giving to the system. So however, the strength of the magnet reduces with the time. Therefore it is therefore there is an extra excitation field found in some design that helps increase its magnetic strength when it reduces. So when the magnetic field reduces, and it is required to replace it. So PMDC does not need field excitation to generate the field flux, as it is produced by the permanent magnet. So permanent magnet, because of the permanent magnet, we not required any excitation for the movement. So this increases efficiency as no extra power is consumed for the excitation. The absence of the windings greatly reduces the size of overall motor. So it is a compact motor. Therefore the PMDC motors have compact design, and it is very cheap as compared to the other motors, and best for the low power application. So that was a brushed type of the DC motor. So now we will discuss the brushless DC motor. So this brushless DC motor, this is also known as the BLDC motor, and is another main type of the DC motor that does not have any carbon brushes or commutators. Now the commutator assembly. So it means the input power is not supplied to the rotating part of the motor, but at the stator of the motor, which is in this case is made of the multiple windings, and we use the multiple winding as compared to brushed DC motor, and the rotor is made of permanent magnet here. So you see on the screen here we are having the brushless DC motor. Now this you are seeing here that there are the windings there. Then we are having a stator winding and the rotor in this type of motor. Now we see that this is a multiple stator windings, each situated at a different angle to generate the flux in different direction. You see here we are having a different stators which are at the different angles, and the different arrangements are here. Now this type of which generate the flux in the different directions. So input in the switched between the stator windings to generate a magnetic field that pushes or pull the rotor's magnetic field, causing it to rotate in its direction. So we use here the sensors, that the Hall effect sensor is used to detect the position of the rotor and the switch the input of the correct stator winding respectively. So here we are having that the rotor rotates, push or pull on the rotor's magnetic field, which causing a rotation in its direction. So this type of Hall sensor are used to detect the position of the rotor and the switch that will give the input to correct the stator winding, so on. And the DC input to the stator needs to be switched. So such electric motors use electronic communications instead of the mechanical communications, using switching devices such as thyristors are we use. These switches are controlled using the microcontrollers to precisely switch the input between the stator windings. So it is essentially switches the DC motor into the three-phase supply, which generate a smooth rotating magnetic field. And this brushless motors speed depend upon the frequency of the power supply which we are giving through the controller. So which is why it is also called the synchronous motor. And the control used for the brushless motor is more sophisticated or very expensive. So it does not operate without any controller, which also offers to the precisely speed control, positioning of the motors. But the cost of the controller is far greater than that of the motor itself. So it is expensive. but there is no brushes, it is brushless, so there are no electrical and electromagnetic noises because we are not using a brushes, carbon brushes here. The spark generated in the mechanical commutation, so it helps in increasing the lifespan of the motor as well as the efficiency of the motor, because we are not using the brushes here, so there is no extra electrical and magnetic noise and the spark in the system. So the efficiency of the motor will increase. The energy dissipated in brushes is converted into the mechanical output. So they are also the maintenance free as compared to the brushed DC motor. And next type of motor is the coreless or ironless DC motor. In this type of motor, as the name suggests, that such a motor, DC motors have no laminated iron core. That's why it is a ironless or the coreless DC motor. The rotor winding is wound in squid or the honeycomb shape to form a self-supported hollow caves, often made using with epoxy. So rotor made of the permanent magnet set as hollow rotator. This coreless design eliminates the issues and losses associated with the iron core of the traditional motors. If you take an example of this, so such electric motors have no iron losses, which increases the efficiency of the motor up to the 90%. So efficiency of this motor are more. So the design also reduces the winding induction, which reduces the sparks generated between the brushes and the commutator, thus increasing the lifetime of the motor. It also reduces the mass and inertia of the rotor, which also increases the acceleration and de-acceleration rate of the motor. So there is another type of, we discuss the AC motor, alternate current motor. Second is the DC motor, that is the direct current motor. Now we discuss the special motor. There are the several type of the special electric motors that are the modified version of the other motors designed for the special purposes. Some of these electric motors are discussed here. So first is the servo motor. As you all know, this servo motor that is used in the water supply. So and moreover, you have seen these type of motor in the creating a vacuum in the laboratories. So this is the one type of the servo motor. This servo motor is specially type of the motor used for pushing and pulling or lifting of the rotating an object at a specific angle. So this servo motor is designed for the run for the AC as well as for the DC supply. And this servo motor that runs on the DC supply is called the DC servo motor, while those which runs on the AC is called the AC servo motor. So on the basis of the requirement, we constructed the AC or DC servo motor. It is a simple motor with a controller and the multiple gears to increase its torque. This type of motor rated in the kilogram per centimeter, and it specifies how much weight the servo can lift at a specific distance. For example, a servo rate 3 kg per centimeter can lift a load of the 3 kg, that is at the 1 centimeter away from its shaft. So it is rated on the basis of the kg per centimeter. It means if we just lift the load of the 3 kg, then we use the servo rated to 3 kg per centimeter. And it means at the 1 centimeter away from the shaft, it can carry the load of the 3 kg. The weight lifting capacity increases with the increasing of the distance. So servo motor has a gear assembly, controller, a sensor and feedback system. The gear assembly is used to decrease the speed or increase its torque significantly. And this another type of motor is the direct drive. This direct drive motor are also which is known as the torque motor, and it is another type of the motor that produces a high torque at the low speed, even when it is stalling. So the payload is directly connected to the rotor, thus eliminating the gearbox, valve speed and reduces extra. And another type is the linear motor. The linear motor has a unrolled stator or a rotor that offers a linear force instead of the rotational force. That's why it is a linear motor, because we are using the linear force. If you slice your motor, lay it flat on the surface, you will get a linear motor. So this is the type of the another motor. Another motor is the stepper motor. This stepper motor is the stepping motor is the brushless DC motor, whose full rotation is divided into the number of the equal steps. So that's why it's a stepper motor. Such motor rotates the steps a fixed degree instead of the rotating continuously, where such stopping movements offers the great precision which lies in the robotics. Not a continuous rotation, but a rotation in a steps, a time after a time interval. That is also in the pulses. That is also the step motor operates on the pulses. Each pulse moves the motor by one step, as you see in the robotic cases. The precision of the motor depends on the number of the steps per revolution. So the step size is determined during its design. However, the speed of the motor can be controlled by applying the pulse train of the variable frequency. And another type of motor is a universal motor. This universal motor is special type of the motor that can run on the AC as well as the DC motor. It is the brushed series wound motor, where the field winding is connected in the series with the armature windings. So they offer the maximum starting torque with a high operating system. So there are some application of the motors. AC motor can be found in the numerous home appliances and the applications. You see the motors in the clocks. You see the motor in the power tools, disk drives, washing machine and other home appliances. We see the motor in the audio, turntables. We see the fans, another pumps, blowers, conveyors, compressors. So they are the many applications of the motors. Thank you very much.